Yeah, hi there. We are continuing with our tutorial on exploratory data analysis. In this, we are going to cover SweetViz Python library. So, what is SweetViz? SweetViz it's an open source Python library that is used to generate some beautiful high density visualizations once we start the exploratory data analysis with a very minimal line of code. So, the output that we get is in the form of an HTML output. So it's a very powerful package that helps to visualize data in an extremely intuitive manner, and it shows a lot of plots and pairwise comparison between the different variables, and we get statistical summary of each of the column. So while doing the EDA, we can use this library. It will help to understand the distribution of the data for each of the variables, find out the relationship between the variables, and that too with a very minimal amount of code and in a very beautiful HTML output. Okay, so to start with, we'll import pandas, import pandas as PD, and we can import SweetViz library. If you have not installed it already, you can install it using the command pip install SweetViz. Once it is installed, we can just import it, import SweetViz, and I'm just checking the version of pandas. It is 1.0.3, and the version of SweetViz is 1.0A7. So what it means is SweetViz currently is in the alpha testing phase. So it currently supports Python 3.6 plus and uh, Pandas 0.25.3 plus. Okay. Now the output that is generated by the SweetViz is based on the OS module. So uh, it probably will. So if we are going to use it in a Google Colab, it probably will not work out as of now. And currently, as of now, the only rendering option supported is in the form of an HTML file. Okay, so let's start with the data set related to the housing data, and we'll try to do exploratory data analysis with the help of SweetViz library. Okay, so I'm just loading the data. One is the train data and other is the test data related to the house. So basically, this data is already divided into train and test separately, so I'm reading it from two separate files. So when the data is read, I can check their shape. So the first is the house train data. It has 1460 rows and 81 columns. The other one, the test one, has 1459 rows and 80 columns. The difference of one column is obviously the target variable, so which is present in the training but not present in the test, and which is what we want to predict with the help of a machine learning algorithm. Cool. So let's see the first few records of the train data, house underscore train, using dot head function and passing n equals to 3 just to see the first three records. So this is what we get. These are the different columns which are present in this data set. So the last column is the sales price. This is our target column. Okay. Now we earlier learned how to do visualization using pandas profiling, but the thing with pandas profiling is that if our data set is pretty huge, in terms of rows and in terms of columns, and also too many categorical columns are there, then it um consumes a lot of memory. It takes a lot of time, and sometimes you get memory ran out of memory issues. So to overcome all these things, we are using this SweetViz library. It is built actually on top of pandas profiling. Okay, so so what we also get in the SweetViz is we get the output in terms of the target variable. So our first line of code to present a report, it's like this. So we will say SweetViz.analyze. Then we are passing our uh, data frame. The data frame that I'm going to use is house underscore train, and this particular string is the representation how this will be represented in the report. So I'm just passing train. We can pass any other value we want to, because this is just nothing. This is just a string representation, nothing more than that. And the target feature. So target feature is our sale price. So once this is done, we collect the output in report. Okay, so during the execution, it will keep on generating the output, like how much percentage is complete. So if you see, it starts from the beginning here, and it starts from each of the variable, and it goes on, and finally after the pairwise processing, it just completes all the work, and we get the output stored in the report. So what is actually a report? The object in which we stored it, this is a SweetViz data frame report. So if you check the type of report, this is a SweetViz data frame report. Yep. Now let's render the output as an HTML. So how do we render it? We say report. This is the object in which we store the output, and we just simply say dot show HTML and the path where we want to display it. Once you execute this, you get an output like this, a beautiful HTML file, which at the very top comprises of this uh, the name that we passed, the train. If you see, we passed here train, the string. That string comes at the top. Okay. Now at the very top level, we get the summary, like how many rows are there, how many duplicates, how much memory is consumed by this data frame, how many feature variables are there. So let's say 80 in this case. Yes, out of which how many are categorical, 54 are categorical, 25 are numerical, and one is the text. Okay, now this is our target variable sales price. So this is highlighted with the black color, whereas other variables, other features are not highlighted by the black. This is just to distinguish that this is a target feature. Okay, now we just quickly have a look what it all actually presents in the output. So this is the training data. We expect all of the records should have a value for the sales price, because that is needed only to train the data. So all the values are present. There is no missing value, and we get the maximum, minimum, and the same like we get in describe function, and the 5 point summary like mean, median, Q1, Q3. 95 percentile is extra, and 5 percentile are the extra values that this is presenting. Okay, then we get like range, IQR, standard deviation, variance, kurtosis, skewness, and the sum. And this is the graphical representation of the data. Okay, let's just, and then next, the first actually feature column is our ID column. Let's skip this. Let's go to the actual column that matters, because ID probably will not make much difference in modeling, so we might skip it later. Okay, let's take this column MS subclass. So this value, so it has all the data, so there is no missing value. It has 15 distinct values. Okay, now we have maximum, minimum, and other uh, statistics like mean, median, Q1, Q2, Q3. So what we see here now, these are the MS subclass values, these rectangular bars that we are getting, and the dots and the lines over it, we see is the average value of the target feature. So target feature is sale price. This is the average value of sale price for this particular data points, and similarly for these data points, this is the average value of sale price. So corresponding to the different data points belonging to MS subclass, it presents the average sale price. Similarly, if you see, there is another variable now, MS zoning. So this is a categorical feature. Now, because of this, we do not see the other statistical data like mean, median, because it doesn't make sense. So we get to see that it has 5 distinct values, and all none of this is missing. So that is, it has data in all the rows. And for these 5 distinct values, this is presented here, that around 80% data belongs to RL, MS zoning. For RM, around 15% data, and this is the average sale price for each of these categories. So that's how we get statistics for each of the variables. Now, if I come here, okay, and I just simply just change the zoom. I'm just zooming in. I On the right hand side, you will see a lot more information compared to the previous one. So this particular value, like what are the other statistics we can see related to the most frequent values, the smallest values, largest values, other things we can see. Now let's select a different one, a categorical one. So MS zoning is the categorical one. I've just selected that particular uh, section, and this is what we get the other values. For example, RL says that 79% of the values belong to RL, followed by RM category 15%, and the average sales price for RL is 191K. So if you see here, the average for RL, the average sales price dot is here, that is around 191K. So for each of the category, we are getting the average sales price, and some other statistics are there. So this we basically get for each of the feature, its distribution, and not only its distribution but also the its distribution with respect to the target variable, that is the sales price. Okay, what else? Okay, another thing that we can do is we can compare the test and train data sets also with respect to the target feature. So what we need to do is we just simply say sweetviz.compare, specify the data sets. House train is the training data sets, and I'm specifying the string to represent it as train, and house test is the test data set or test data frame, and the string to represent it should be test. Again, the target feature is sale feature. So once we run this, we store the output in train test comparison report, which is nothing but a Swiss Viz data frame report. And if we render it, we get output like this. So now you see the blue ones are the training and the orange one is the test. For sales price, obviously, since only uh, the train data has the sales price, there is no sales price in the test data because that is what we have to predict. That is why you don't see any orange color bar in it. So let's ignore this ID. Let's ignore that also because ID we will be skipping for modeling purpose. Now let's take this one, MS subclass. Okay. Now this is what we have. So this is a comparison between the blue one represents the train and the orange one is the test data. So it's for each of the values, for each of the range of the values, we have a comparison between the train and the test and the average price. This particular line, blue line, represents the average sale price. That is the average value of the target feature. Now let's go to the MS zoning. For MS zoning, let's do a comparison between the blue and the orange, that is between train and the test. So we see 79% data belongs to RL category in the train, whereas it belongs to, so whereas in the test data set, this RL category belongs to 77%. So for RM, it is 15% in train and 17% in test. And then we have the average sales price for each of these categories. So in this way, we get a comparative study between the test and the train data frames with respect to the uh, sales price of the house or whatever the target variable is in the data set. So that's how what we can do the quick exploratory data analysis by using the SweetViz. So as you know, this is in the alpha testing phase. It is not fully ready yet. So if at all, let's say if any one of us faces some issues, then maybe we should go ahead and log our bugs so the developers can actually check into it and help to improve this library. So that's it for now. Thank you.